draw a cute triangle that is scalene, which means no sides are congruent. Okay? And what we're going to do, our job today is to actually find the orthocenter. So what we're doing is we're finding the orthocenter today. The orthocenter is the intersection of three altitudes. So it's the intersection of three altitudes. And what do you guys remember about altitudes? Does everybody know anything about an altitude? It brings straight down to a right angle. Yeah, okay, we're going to do that. We're going to make three of these in one triangle. And by making three of these in one triangle, we're going to come up by what's called the orthocenter. Here we go. Put the vertex, put your pointer on one of the top vertex up here like this. Drop it down just a little bit farther than the actual line and make an arc like this. And then we're going to measure that arc, and I know that I'm measuring that arc because I'm going to see a little slash right there. I'm going to arc this down like that. I'm going to turn it around. I'm going to measure that again, and I know that because I have a little slash there. And I'm going to arc this down like that. And by dropping that down, I'm measuring the height of my triangle, and the height of my triangle is my altitude. Okay, so right now, what we have, from the vertex to the intersection is my altitude. Now, an altitude does not cut the length in half. It does not cut that base in half. Only on some triangles, like a equilateral or an isosceles triangle, but on this one it doesn't. Okay? Let me get a blue pen. Okay. Now we're going to draw another altitude from another vertice. Okay? So I'm going to go from this vertice right here. So I need you. Yes, sir. Yes. So what I need here is from this vertice right here, I need to draw another altitude. Now the altitude measures the height. Now I know you guys could take your paper and turn your paper around to make it so this is going straight down. But I don't. And what I need you to understand is because the altitude in a triangle measures the height, this right here is going to be measuring, I'm going to be measuring my height to this side. This length might not be long enough. So I might have to extend that a little bit. So what I'm going to do, just for right now, is I'm going to see just in case I have to extend this, I need more line. I'm just going to extend that just a little bit, just in case. Okay, so you put your pointer on your vertex right here. And again, you drop it down just a little bit farther, and you arc up like that. Okay? And now we're going to measure our arc. And how do I know I'm measuring the arc? Make a little slash like that. And then I'm going to arc down. Well, I might have to arc up then. And then I'm going to turn it around. If I can't arc down, then I'll arc up. How many points do I need for a line? 2 points. Okay, so what I'm going to do now is connect the 2 points. The 2 points that I have, because I can't get that intersection up there, is my vertex and this point right here. Okay, so now we have this. Okay, now if my orthocenter, which is what I'm trying to get at, is the intersection of 3 altitudes. Here's one of my altitudes right here. This altitude needs to be longer right here. And so I might just extend that a little bit just to show, oh yeah, I am going to have an intersection up here. But just to be sure, I'm going to draw my intersection, I'm going to draw an altitude from my other vertice. Okay? So now we're going to draw the vertice, the altitude from this vertice, which goes from here a little bit longer. Now look what happens, you guys. Look what happens when I make my arc. What happened? What happened? what am I missing? Part of my triangle, part of my line segment. And if I don't have enough line segment, what I need to do is extend my length a little bit. And that's totally fine to do that. Extend the little line, because what that does is it shows me that I have a length that intersects in two places, because that's what I need. So now I'm going to measure that length from here to here, and measure it, and then I'm actually going to arc up, and then I'm going to turn it around, measure it again, and arc again. Boy, it sure looks like this line right here from my vertice goes right through here, doesn't it? Okay? So what I end up having is an altitude right here that came straight down. So I have 3 altitudes. They all intersect in one place. And then what do I do with that? Since they all intersect in one place. What's that called?
Circumcenter.
No?
Ortho.
Orthocenter. So orthocenter. We're going to do the circumcenter next. Okay, you guys ready? Draw an obtuse triangle.
We'll just go by that.
Andrew, I did this one all. This is a different one. So this will be better. Okay, so you guys are going to do the circumcenter next. On a piece of scratch paper, I need you to draw an obtuse triangle. Draw an obtuse triangle. Okay? Everybody draw an obtuse triangle. Bless you. Who is sneezing? Is that Kira? Paula? You're sneezing?
No, you do it, so.
All right. Okay, here we go. Obtuse triangle. What are we making? No, what's our job here? Circumcenter. What is a circumcenter made of?
3 points.
3 intersection of 3 points, but where are they from? Intersection of what? 3? Yep. 3 perpendicular bisectors. Okay, so here we go. This is how you do it. First one, bisect the length of one side. Okay? Measure the side. Measure it. Arc up. Arc down. Turn it around. Measure it. Arc up and arc down. Okay? You need 2 points to make a line. We have that. Draw the intersection of those 2 points. Because this is a perpendicular bisector, it actually does 2 things. It bisects the length of one side. It also makes that a perpendicular line that cuts through. It makes a midpoint in between them. Okay, next one. Bisect the next side. Measure the length of this side. Arc up. Arc down. Turn it around. Measure the length of this side. Arc up and arc down. Okay, draw the 2 intersections of those 2 points. And because I'm trying to find the intersection of my 2 or 3 perpendicular bisectors, to find that, I might make my perpendicular bisectors a little bit longer so that I can see the intersection, which I can already actually see. But let's just make sure we're going to bisect the 3rd side. Okay, so we're going to bisect this side like this. We're going to arc up. Uh-oh. Okay, sorry, Amelia. And then we're going to arc down. Turn it around. We're going to arc up and down. And there it is, right there. Okay, make your intersection. And that, I need a longer bit, I guess. Okay. so you guys should have the intersection of 3 perpendicular bisectors makes a circumcenter. Okay, there's my circumcenter. Now, once I have that circumcenter, just for your information, what can we do with that? Circumscribe a circle about the triangle. So, and what professions might this come in handy?
Engineers.
Architect, engineering, pediatricians. Okay, here we go. Put your point on the vertex right there. Put your sharp point on the intersection, which is your circumcenter, and take your pencil and move it all the way down to 1 vertice. Any vertice will work, pick one. And without moving your point, and try not to move this, you're going to draw an arc all the way around, and it should touch each vertice if you did this correctly. Oh, excellent. Okay. And I'm coming down. Oh, yeah. All right. Okay, so we have a circumcenter, and we have circumscribed a circle around our obtuse triangle. Okay.